Next up, we're going to look at annuities. Annuities. Now, an annuity is a constant amount that is paid or received for a number of periods. If it's 1 million rand that is payable every year for 5 years, that's an annuity because you're paying an equal amount for a certain number of periods. Okay, that is what an annuity is. That's the definition of an annuity. Okay, so imagine people get their pensions paid out annually or monthly, and they keep getting the same amount every month. Okay, or they keep getting the same amount every year. That is an example of an annuity. All right, so what we're going to do is to find out how do you calculate the present value of an annuity. Obviously, the first thing that will come to mind is, since you already know how to calculate the present value of a single payment, maybe you can just calculate the present value of every single payment or every single annuity that's going to be paid. That can work, but what if the annuity is for 50 years? Are you going to have 50 separate calculations? It gets very tiresome. Okay, so we're going to look at other ways of doing it. Okay, so let's look at an illustration, then we jump into the calculations without wasting much time. So here's an example. Suppose I expect to receive £1,000 per annum for 3 years, starting in 1 year's time. And I want to calculate the present value using a discount rate of 5%. Okay, how do I do it? I want to calculate the present value using a discount rate of 5%. So there are 3 ways of doing it. Method number 1, which is the long and cumbersome one, you discount each cash flow separately using the present value or the discount factor. Okay, so you discount the year 1 annuity of £1,000 at the rate of 0.952. That's our discount factor for year 1 at 5%. And then you discount year 2's cash flow with discount factor 0.907. Then you do the same for year 3 at a discount factor of 0.864. Okay, and then you get your present value to be £2,723. But I would like you to notice that if we add together all those discount factors, it gives us 2.723. 2.723. And is it a coincidence that 2.723, if you multiply it by the principal, which is £1,000, you'd get 2,723, which we have calculated to be the correct present value? I don't think it's coincidence. So let's look at method number 2, which explains why that is actually the right way of doing it. So method number 2 is you'll be using what we call a cumulative present value factor. A cumulative present value factor. So how this cumulative present value factor is calculated is you simply add all those individual discount factors for all of those years. So this was for 3 years at 5%. So you add the discount factor for year 1 at 5%, for year 2, and for year 3. And the total would give you 2.723. Then you simply multiply it using, you simply multiply future value that is in question, or the annuity that is in question. Okay. So the good thing about this is, again, mathematicians have made our job easier. They've prepared tables for us where we simply go to the table and pick up the annuity factor that we want. Okay, so if you go to the annuity factor tables, which you will be provided for in the exam, and you must have a copy now, you will get them in the textbooks as well. So you just simply go to that table, you look under 5%, 3 years, the present annuity factor table will give you an annuity factor of 2.723. So remember, the present value of an annuity now is going to be calculated as the annuity multiplied by the cumulative present value factor. The one thing I must emphasize at this point is, do not confuse the cumulative present value table for the present value table or vice versa. Those are 2 different tables. However, in appearance, they look exactly the same unless you look closer to look at the figures. Okay, you will never get a discount factor that's in the present value table. You will never get a discount factor that is greater than 1. So if you look at your tables and all the figures are just jumping above 1, getting to 2.7, 5 point something, then you know you're looking at the what? Cumulative present value factor, which is only used when you are calculating the present value of an annuity. Nothing else. It's just for an annuity. Please remember that. The cumulative present value factors are only used for annuities. You cannot use them for single payments, single year payments, and you cannot use it for perpetuities. It's just for an annuity. Then method number 3 is to use the formula. Now the formula has been given in the exam. However, it doesn't hurt for you to cram it and remember it. It's This formula is for calculating the annuity factor. It's for calculating the annuity factor. Once you get the annuity factor or the cumulative present value factor, then you multiply it by the annuity itself. So it's called the annuity factor or the cumulative present value factor. Okay, and it's calculated by saying 1 over r, where r is a decimal, multiplied by 1 minus 1 over 1 plus r to the power of n. That's the formula. Okay, so using it for our last example, we will more simply 1,000 pounds, that is our annuity, multiplied by, then we now start calculating the annuity factor. It's 1 divided by 0.05 multiplied by 1 minus 1 over 1 plus 0.05 to the power of 3. And you'll find the answer is going to come to 2,723 as before. All right. So those are the 3 ways we can do it. So again, I've attached a little table, an annuity factor table, where you can look under 5%, go to 3 years, you'll see there's 2.723. So you're given percentages 1 to 20, and then years 1 to 15. So if I wanted to see this same annuity, this very same annuity of 1,000 pounds every year, let's say it's at 8%, and I want to see what it will be at 15 years, at the end of 15 years. I simply go to 8%, go down until I get to period N is 15, and you find the annuity factor is 8.559. So I simply say that 1,000 multiplied by 8.559. And then that's it. That's how you use tables. They are very quick and helpful in the exam. Okay, you need to keep a copy so that when you're doing revision, you don't have to waste time punching the numbers in the calculator using the formula. Okay, this is a very simple calculation, and so try not to waste time and familiarize yourself with using these tables. So I've set a little example. It's example 8, which says a new machine will generate an additional 3,333 pounds per annum for the next 4 years. The first cash flow starts in 1 year and the discount rate is 5%. Okay, so again we're using 5%, but this time it's for 4 years. And the annuity is 3,333. So part A of the question says calculate the present value of the annuity using the annuity formula. So if you're using the annuity formula, you're going to say 1 over 0.05 multiplied by 1 minus 1 over 1.05 to the power of 4. And you get your annuity factor, then you multiply it by 3,333. And then part B says recalculate the present value of the annuity using the tables. Now you're using the tables. So we're going to do this calculation together, just so that you really understand how we do this. Okay, so let's attack this question. A is asking us to use the formula, right? That's part A. It's asking us to use the formula. Now, so for us to calculate the present value, it's just going to be present value is equals to 3,333 multiplied by 1 over the rate, which is 0.05, right? Multiplied by 1 minus 1 over 1.05 to the power of how many years? 4, like that. Okay, so just simplify it on your calculator. Oh, close brackets there. And the answer should come out as 11,819 pounds. That's the answer if you're using the formula. That's how you get, this is your annuity factor formula there. Then part B is asking us to use tables. Now for using tables, our present value is going to be that 3,333 multiplied by the annuity factor that we're going to get from the table. So we go to 5%, go down and look at what is the value under 4 years and 5%, and you're going to get 3.546. And then if you multiply it together again, you're going to get 11,819 pounds, like that. So it's very easy. Just go to the table, look under 5%, that is the annuity table or the cumulative present value table. You look under 5%, go down to 4 years, take the number there. And in this case, it's 3.546, and you get the same answer of 11,000 pounds, 819. All right. Now we're going to look at some variations in annuity calculations. So we're specifically going to look at advanced annuities and delayed annuities. Okay, so the normal calculation we've been doing so far for annuities assumes that the first payment is coming in 1 year. Okay. However, there are situations where you may have an advanced annuity, in which case the payment that you're going to receive starts now at year zero, at time zero rather. So in such a case, you have to modify your calculation a bit. And then there are also situations where an annuity will come, however, you will only receive the first annuity some years or some periods from now, not in year one. Okay. So in other words, it begins after year one. That's a delayed annuity. All right. So you can't just use that formula unchanged because it will distort the answer. The formula for those annuities, when you're using the annuity factors, assumes that the first payment is going to be in a year's time and it will continue for n number of years. Okay. So if you've got a delayed annuity or you've got an advanced annuity, you have to modify your calculations slightly. So we're going to look at how that can be done in practice. How can we do that for our calculations for exam purposes? So we're going to look at this example. It says, using the information in example 8, calculate the present value of the annuity using the tables if A, the annuity begins immediately, and B, if the annuity begins in 3 years' time. So A is an advanced annuity, you get your first payment now. B is a delayed annuity, which will only start in 3 years. Okay. All answers should be rounded to the nearest pound. So we're going back to example number 8 and see what it was saying. Okay. So it said a new machine will generate additional 3,333 per annum for the next 4 years. So for part B of the new question,